the length of the segment. But more on the involved operation in finding the length of the segment is multiplication and division. So the first theorem that we have to find the length of the segment in the circle is when a chord intersect, the chords break into segments that are equal when multiplied. So that means when there are two chords in our circle and they intersect to each other, forming an angle, those segment that is being formed by the chord will be equal once we multiply, just like what we have on the screen for circle X with a chord of AB and chord CD. The chord AB and chord CD intersect that form for segment. The segment AX, we have segment AX, we have segment XB, and we have the segment CX, and the last segment that we have is segment XD. So if that two chord intersect, when we multiply the corresponding segment that is being formed in that chord, it will be equal, just like what we have here. AX multiplied by XB is equal to CX multiplied by XD. For example, we're going to apply it in a circle and we need to find the measurement of the specific segment. For example, we have the circle. It has a chord that intersect For example, this is our circle. We have chord MN and chord. The two chord intersect in a point which is O. So we form segment MO, segment ON, segment OA, and segment OB. So let's say the measurement of segment MO is equal to 4 centimeter. Segment ON measures 3. And we need to solve for the measurement of segment AO or OA. And the measurement of segment OB is 2. So we need to find what will be the measurement of this segment, which is segment OA, from the chord AB that we have in our circle. Following the theorem, when the two chords intersect, we're going to multiply the segment that is being produced by our chord. So we have MN MO multiplied to segment ON, which is equal to the segment AO multiply to segment OB. Okay. MO has a measurement of 4 inches. ON has a measurement of 3 inches, which is equal to the measurement of AO, which is unknown, times the measurement of OB, which is 2. So, perform the operation indicated in the problem, which is 4 times 3 is equal to 12. And AO times 2 will be equal to 2AO. Since we're solving for segment AO, we need to remove the coefficient 2 in the 2AO. So divide both sides by 2. So segment AO has a measurement of 6 inches. So that's how we use the theorem when two chords from the circle that we have intersect to each other, forming four segment. There with this theorem about the chord. Before we proceed with another theorem, okay na. Let's proceed with the another theorem that we have in regarding with segment. Next theorem we have when two seconds intersect a circle, the segment of the seconds or the chord together. It means two chord or 2 second of your circle will combine or they will be forming one angle only. Just like what we have here on the screen. And a segment, which is MNO or a line segment MO. And we have also line M. So to find the measurement of a specific segment forming or from our chord, we're going to multiply second and the chord. We have here, for example, we have second MN multiply to a chord MO. So this is the second, the line segment outside of the circle will be multiplied to the whole chord. So MN multiplied to MO and MP multiplied to the whole chord MQ. That's what we're going to use this theorem to find a specific measurement of our chord or segment. For example, we have this circle. For example, the measurement that we have in this circle is this one. So let's say the measurement of MN is equal to 8. Let's say MN has a measurement of 8 and MP has a measurement of 6 and PQ has a measurement of 10. And we need to find out what is the measurement of the chord NO. This is, let's say this is X, since it's the missing measurement of our chord. And in the theorem that we have according to segment and chord, if they intersect or form one angle, we need to multiply the segment and the whole chord. So given that we have MN, which measures 8, multiplied to the whole measurement of MO, which is 8 plus X. So multiply 8 plus X equals MP has a measurement of 6 multiply to the whole measurement of a chord, which is MQ, 6 plus 10. So 8 multiplied to 8 plus X, since we cannot add 8 plus X, so we're going to multiply 8 already by using the distributive property. So 8 times 8 is equal to 64. 8 times X is equal to 8X equals to 6 times 16. Since 6 plus 10 is equal to 16, so we have 64 plus 8x is equal to 6 times 16. So 64 plus 8x equals 16 times 6 is equal to 96. So combine similar terms. So we're going to transpose 64 on the other side of the equation. So we have 8x equals to 96 minus 64. So 8x is equal to 32. Divide both sides by 8. So x is equal to 4. That means the measurement of the chord or the segment NO is equals to 4. So that's the measurement of our line segment NO, which is equal to 4. So that's how we use this theorem about the chord and the secant, forming one angle. That's when we multiply the secant and the whole chord, it will be equal. Okay? Question about this theorem? Oh, sige, let's have another example for this theorem. Can I clear the screen? For example, we have this circle, applying the theorem about secant and chord. The second theorem that we have about finding the length of a segment. So for example, this is our circle. Let's say we have, this is that A. So let's say we have the chord AC and chord AE with a second AB and AD. AB has a measurement of 7 centimeter. AD has a measurement of 6 centimeter. And DE has a measurement of 13 centimeter. And we need to find what is the measurement of the segment BC. So we need to solve for this line segment. What will be the length of the segment BC? Given that the measurement of our second AB is 7 centimeter, second AD, which is equal to 6 centimeter, and second DE, which is 13 centimeter. Following the second theorem about finding the length of segment, we're going to multiply AB, multiply to the whole chord, which is AC, equals to the second AD, multiplied to the whole chord AE. So AB has a measurement of 7 centimeter, multiplied to the whole measurement of AC. Since BC doesn't have a measurement, let's say this is X. So the whole measurement of the line segment or chord AC is equal to 7 centimeter plus x equals AD has a measurement of 6 centimeter multiplied to the whole measurement of AE, which is 6 plus 13. So we're done substituting the correct value of each line segment that we have in our circle. So we can proceed in solving the operation. So 7 centimeter times 7, which is equal to 49. 7 times x, which is equal to 7x, equals to 6 centimeter multiplied by the sum of 6 plus 13, which is 19. So 49 plus 7x equals to 6 times 19, which is equal to 114. So combine similar terms that we have in the problem. So 7x is equal to 114 minus 49, which will be equal to 7x equals to 65. So 65 divided by 7. So the value or the measurement or the length of segment BC is equal to 9.3 centimeter. So that is the length of the segment BC that we have in our circle. Okay na? When it comes to chord and secant, the second theorem that we have, finding the length of the segment.
Only two, right?
No, we still have many theorems for finding the length of our segment. Okay, so let's proceed with the third theorem that we have.
Did you have a question?
Yes, Bob.
How many theorems are there?
If I'm not mistaken, we have 5 yata. 5 theorem. So the next theorem that we have is the tangent and the secant. So when we say tangent and secant, one line segment is a tangent. When we say tangent line, it's connected only in the circumference of the circle. So for example, here in the circle that we have on the screen, the tangent is this one. It's connected only in the one point of the line is connected or intersected to the circumference of the circle. That is tangent segment. So the next theorem is about tangent and secant. So for the tangent and secant, to find the missing measurement or the length of the secant of the segment, we're going to multiply the chord GF multiplied by the whole secant. So secant times the whole chord, like GF multiplied by the whole chord GD. As you can see here. GF multiplied by the whole chord GD. And it will be equal to the tangent. In finding the measurement, since it's tangent, you're going to square the measurement of that tangent. So we can say we have GF multiplied to GD equals to CD squared. That's the theorem when it comes to tangent and a secant. One tangent forming an angle with a chord, and a secant. So to find the measurement or the length of a segment in that circle with that part, which is the tangent and the secant, we're going to multiply the secant multiplied by the whole chord, which is equal to the squared of the tangent. For example, we have this problem. For example, the measurement of our tangent is equal to 30 and chord GF is equal to 25 and secant FT is equal to X. So we need to find what will be the measurement or the length of the segment FT. Given that the tangent is equal to 30 and a chord which is equal to 25. So we're going to solve the segment FT, the length of this segment. So given the theorem, so GF GD multiplied to DF equals to CD squared. So GD has a measurement of 25 plus X. That's the whole measurement of the chord GD multiplied by the measurement DF, which is X, equals to the squared of the tangent line that we have, which measures 30. So 25 plus X, we cannot add it, so we're going to multiply X to the quantity inside of the parentheses. So 25 times X is equal to 25X. X times X is equal to X squared. Have G F multiplied equals to 30 squared. So 30 squared is equal to 900. So since we have squared in the value of x squared, we need to remove the x squared by getting the square root. So square root of 25 is 5. Square root of x is x. Equals square root of 900, which is equal to 30. So since we already removed the square root, we can now proceed in combining similar terms in our problem. So 5x plus x is equal to 6x equals to 30. Divide both sides by 6. So x it's equal to 5. So the length of the segment FP is equal to 5. So that's how we use the theorem at tangent and a secant. So let's have another example using a tangent and a second theorem. Can I clear the screen with this one? For example, we have this circle that has a measurement of a line tangent, which is 24, and a second, and a chord, it measures the x, and 12. And we need to find the length of the segment GF. So we need to find the measurement of our segment GF, following the rule or the theorem about a tangent and a secant, which is DF multiplied by the whole chord GD equals to CD squared, or equals to the tangent. So DF multiplied to the whole chord VG or GD equals to the tangent. So DF has a measurement of 12 multiplied measurement of GD is equal to 12 plus X equals to the measurement of our tangent, which is 24 squared. So 12 times 12 is equal to 144. So we have 144 plus 12x equals 24 squared is equal to 576. So transpose positive 144 on the other side of the equation. So we have 12x equals to 576 minus 144. So 12x equals so 576 minus 144 equals to 432. Divide both sides by 12. So the length of the segment GF is equal to 36. So that is the length of the segment GF that we have in our circle. Question in this theorem. Okay, now with this theorem about a tangent and a secant. So yeah, let's proceed with the next theorem that we have. The next theorem that we have, if the two segments are tangent to a circle from the same external point, then the segments are congruent. The ECS theorem that we have about finding the length of the segment. If we have two tangent with the same endpoint, or they form an angle, that tangent line is congruent. For example, we have here in the circle a tangent AB and tangent AC. And they have their common endpoint, which is A, forming an angle A. The two tangent form an angle, which is A. So these two tangent, tangent AB and tangent AC, is congruent. So if AB is equal to 6, AC is also equal to 6. So let's apply this theorem in finding the measurement of our line segment. If we have two tangent, given that we have a circle F with a tangent HK and tangent HG, we need to find the measurement of the tangent HG. Given that the measurement of HG is 4 plus 2A and HK is equal to 5A minus 32. Since they are two tangent, that means the measurement of these two is equal. So HG is equal to the measurement of HK. So HG has a measurement of 4 plus 2A equals to the measurement of HK, which is 5A minus 32. So combine similar terms to find the value of A. So 2A minus 5A equals to negative 32 minus 4. So 2A minus 5A will be equal to negative 3A equals negative 32 minus 4 is equal to negative 36. Divide both sides by negative 3. So the value of A is equal to positive 12. So we are done finding the value of A. But what we need is the exact measurement of our tangent HG. So we're going to substitute the given value of A to the measurement of HG, which is 4 plus 2A. So HG is equal to 4 plus 2A. So 4 plus 2 times the value of A, which is 12. So 4 plus 24 is equal to 40, 28. So that is the exact measurement of our tangent HG, which is equal to 28. So that's how we are going to use the theorem about HG. Okay na, with this theorem, it's about the two tangent, which is equal or congruent to each other.
Example.
Sige. Let's proceed with the next theorem that we have. Yes.
May I use the CR?
Yes, you may.
Yes.
Let's proceed with the next theorem that we have. Natin kung meron pang theorem dito. For example, we have this circle and we need to find the measurement or the length of the tangent RS, given that the tangent measures x over 4 and tangent RT measures x minus 6.3. So we need to find the exact measurement of the tangent RS. So we're going to use the theorem about two tangents forming one angle. But if we have two tangents, they are congruent in measure. So RS is equal to RT. So if RS is equal to X over 4 and RT is equal to X minus 6.3. Can you try what will be the value of X for us to find the exact measurement of RS?